Welcome to the Parsec, the platform abstraction for security session. I'm Guillaume Gardet. I'm software engineer at ARM, and I'm part of the distro team dedicated to SUSE and OpenSUSE. The agenda for today will be the following. We'll start with an overview of Parsec. Then we will follow with Parsec in SUSE and OpenSUSE distributions. And we'll have a quick demo of Parsec running on the Raspberry Pi 4 using the software backend, but also the TPM backend. And we will have a quick look on the future with the roadmap and how to join the community. So, overview of Parsec, what, why, and how, the Parsec tool, and the multi-tenancy. Parsec is a collaborative project, part of the Cloud Native Computing Foundation, CNCF, as a sandbox project. It is licensed under Apache 2.0 license, and it's already available on multiple Linux distributions, including Fedora and OpenSUSE. If you want to have a look about this project, you can go to GitHub with github.com/parallels_second. Parsec stands for Platform Abstraction for Security. This is a portable interface to your platform's root of trust in order to manage keys and also perform cryptographic operation, but without knowledge of the hardware. This is a simple and portable way to access the security of your platform in your preferred programming language. We currently have a few backends available. You have Embed TLS, which is software backend. You have the TPM backend for trusted platform modules, and also PKCS 11 backend for hardware security modules. So here you have your application on top, and at the bottom you have your hardware. Could be any platform, any architecture, and you can have some dedicated hardware for security, such as a discrete TPM, a firmware TPM, local or remote hardware security module. If you are on ARM, you can also access T services, and we could imagine some custom hardware. And in between, you have Parsec to have a good abstraction layer. On the conceptual view, you have the user on one side and your hardware on the other side. And the user just use the client library to access the hardware. And this is done via IPC wire protocol to access the service. But this is really transparent for the user. So you will have your application, which is platform agnostic. And thanks to the client library, you can access the Parsec service through IPC. This is a wire protocol based on PSI Crypto API. And the Parsec service will do some access control, and thanks to some providers, some backends, it will access the hardware. So it could be a TPM, hardware security module, or a trusted application for Cortex-A based machine. Also, you have a convenient tool, which is Parsec-tool. This is a command line interface for Parsec service. And with it, it's not mandatory to have a standalone application to access the Parsec service. So you have the Parsec tool, command line on one side, and you want to access the Parsec service, which is a systemd service. And the communication is done through the Parsec API calls via the wire protocol, which is currently based on client-server communication using some Unix domain socket. One important thing of Parsec is multi-tenancy. Your cloud native workload delivery at the edge is expected to be multi-tenant. You have multiple applications which share access to the secure hardware on the platform, and each application needs a unique and persistent identity, which is assigned by a component that Parsec can trust. The Parsec service treats each API call according to the identity of the application that made the call, and partitions key stores and brokers access to hardware based on the identity. The source of identity depends on the deployment, but it could be a container runtime manager, for example. And anyway, a deployed system requires an identity provider, a separate component that assigns identities to applications, which has a trust relationship with the Parsec service. So for example, your application via the Parsec client library make some request to Parsec, and Parsec will verify your identity thanks to the authenticator. And the operating system can validate or invalidate it. Now we can have a look at Parsec in SUSE and OpenSUSE world. We will start with the availability. So we have currently 2 RPM packages available. So you have Parsec, the systemd service, and Parsec tool, which is a command line interface. Those 2 packages are built for multiple architectures. So it includes x86, AR64, and even PowerPC. And this is packaged for OpenSUSE Tumbleweed, of course, but also in OpenSUSE backports SLE15 SP3. So it will be available in Package Hub for SLE15 SP3, but also for OpenSUSE lib 15.3. Parsec is tested in OpenQA for Tumbleweed as part of extra test console test. Currently, only the software backend is tested, and we may add some more tests in OpenQA, maybe with the TPM support, but it's not yet there. To install it, you do as usual with Zypper or Yast to install Parsec and Parsec tool packages. Once done, you will need to add your user to the Parsec clients group. So it can be done with Yast or from command line. But keep in mind, you need to relog in with this user to get the changes in effect. Otherwise, you can use the new grp command to enable immediately the Parsec clients group. Then you will need to update the configuration file if needed, because by default it only provides the embed TLS backend, which is a software backend. So for example, if you want to enable your hardware security module or your TPM, you need to edit this file. You have a full template in user share doc packages parsec config.toeml. This is installed as part of the Parsec package. Now you can start the Parsec service with a systemctl call, as usual for systemd service. And you can check that your Parsec service is up and running with Parsec tool ping. it should return Service Wire Protocol version 1. With Parsec tool, you can also list the providers. So in this example, you have embed crypto provider, also TPM provider, and the core provider. One important thing to note is the ID, because this is what you will use with Parsec tool to address one or the other of the backend. With Parsec tool, you can also get more information about opcodes available for a given backend. So Parsec tool list opcodes dash provider one will list all the opcodes for embed crypto provider because ID 1 is embed crypto. You can also list the keys. So at the beginning you have no keys. And you can create RSA or ECC keys for each provider and for it and you also need to provide a key name. And once you have created new keys, you can list the keys again. And you can see that with those two commands, it created two keys, test and test ECC keys from embed crypto provider. You can also export the public key to make use of it. And you can also use Parsec tool to decrypt some uncoded text with a given key. Of course, you can also delete a key with Parsec tool. And you can generate random numbers. So you can generate n bytes with Parsec tool. Please note that not all backends allows to generate random numbers. So now we will have a quick demo of Parsec running on the Raspberry Pi 4 with OpenSUSE Tumbleweed. This is with Parsec 072 and Parsec tool 030. It will show the embed TLS backend, so the software backend, but also the TPM backend, because we have Let's Trust TPM hardware from Pi3G, which is right there. And if you want to add TPM support for your Raspberry Pi 4 or Raspberry Pi 3, you can go to the OpenSUSE wiki and check out this link, and you have all you need to know to get it up and running. So let's switch to the demo. So we connect to the board via SSH. So as I told you before, it's running OpenSUSE Tumbleweed. This is from a Justinus OS image. And I just added the TPM support and created a regular user. So for the TPM support, I created the boot EFI extra config.txt. So this is for device tree overlay and device tree parameter to enable the TPM. And I also created a file in etc modules-load.d to load the TPM-TIS SPI kernel module automatically on startup. With those two files updated, you can now use the TPM on boot. So now we can install Parsec and also Parsec tool packages. So you have some mandatory dependencies, but also some recommended packages. The recommended packages are useful for other backends, so you might ignore them if needed. Okay, so now Parsec and Parsec tool are installed. So we can have a look at the config file in etc parsec config.tyml. So by default, as I said before, you have only the embed crypto provider enabled. And here we want to enable the TPM provider. So in the config file, you have some default and for the TPM, but you just need to remove the hashtag. Here it will use a /dev/tpm rm0, which is TPM device number 0, which is the case here because we have only one TPM. And you can see that we have the embed crypto provider as well. Now the config file is up to date, so we can start the Parsec service. It takes some time to start, but it is expected. And now we'll check that the Parsec service is up and running. For that, we will use Parsec tool with the ping option. And you can see an error, which is in fact expected because the current user is not part of the Parsec clients group. So we need to add this user to the right group, and we can do it from command line or from Yast. So the Yast user module is starting. Okay, so let's edit the current user. And we go to additional groups to select Parsec clients. Okay, so now we need to log out and log in again to get the groups updated. And now we can ping again the Parsec service and it works. Service wire protocol version 1. So let's run some other commands. So we can list the providers. So you have the embed crypto provider with ID 1. You have also the TPM provider with ID 3. And you have the core provider, which is not a real backend. This is more for administrative tasks, which means non-cryptographic operations. And this is with ID 0, but we will not use it. So 1 is software backend and 3 TPM backend. We can also list the opcodes for each provider. So let's start with provider 1, which is embed crypto, software backend. And you have lots of opcodes available. And if we do the same for the TPM backend, you only have a subset of the opcodes available. We can list the keys, which is an empty list for now. So let's create some RSA key. We'll start with a key from software backend, which is named just test. If I list the keys, now you can see the test key from Embed Crypto Provider, which is a RSA key. We can also create another key, this one for the TPM, so for provider 3. And we can change the name and call it test TPM. Okay, the second key is created. If I list the keys, I have my two keys. Test TPM with TPM provider is here now. Now we can export the public key to share it. So we can export the key from Embed Crypto Provider, which is named test. And we can do the same for the TPM key. So here we have an error because Parsec tool is trying to get test TPM key from Embed Crypto Provider. So we need to use the provider 3 for this key. And now it works. So we can share this key to encode some data. So let's start with test TPM key. Here it is a website which allows to encode some text with some public key. So the message is have a lot of fun, and I can copy paste the encrypted output, and I will use Parsec tool to decrypt it. So the command is Parsec tool decrypt, and of course I need to pass the provider option. So this is a TPM backend, so provider 3. With decrypt and take as argument the encoded data. And of course I need to pass the key name, which is test TPM here. And here is the decrypted text, which is have a lot of fun. We can perform the same thing with the other backend. So we just change the public key, we keep the same message, and now we copy paste the new output, and we use Parsec tool decrypt with provider 1, of course. With key test. And here we go, have a lot of fun. Another thing we can do with Parsec tool is to generate random number. You can also sign data, delete keys, etc. So let's delete a key for now. So we need to pass the key name, of course. Now I deleted the key named test from the embed crypto provider. And we still have test TPM key from TPM provider. Now we will generate some random numbers. So we need to pass an argument, which is n bytes, to know how much to generate. So let's start with 1 byte, but you can generate 1 kilobyte. And that's it for the demo. You have another nice demo from Paul Howard on ARM Software Developer channel on YouTube, where Parsec is used with a Nitro key hardware security module. And in this video, the PKCS11 backend is used. So you can just click on the link or flash the code and you will jump on YouTube. Let's have a look at the future, especially on the roadmap and how to join the community. So currently you have the software backend, of course, but also TPM provider and PKCS11 provider, which are ready. So you can access your hardware security module or your TPM. And you have some work in progress to add some crypto OSLib provider. And also some work in progress for trusted services. So this one is specific to Cortex-A platforms, where you can have some trusted application running in a trust zone with Opti. On the client library landscape, you have the C library ready and also Rust library. Go library is still work in progress, and Java and Python are not ready yet. Here is full functional support map. So about the front end, you have the Rust client and C client, as I told you, and Go client is still work in progress. On client authentication, you have only peer credentials for now, and SPF identity is work in progress. For the wire transport, only Unix domain socket is available for now. And for OS support, you only have Linux, which is fine for us. On API, you can see that some are ready, some are still work in progress, and some are still to do. And for the backend, we are in good shapes with TPM, PKCS11, and Embed TLS ready, and work in progress for Crypto OSLib and PSI services in Opti. So the last one is only for Cortex-A, whereas all others are available for all architectures. You can join the community to help. So you can have a look on GitHub, AbstRaction community. You can join the community on Parsec channel on Slack. And a meeting is held on Zoom every week. Thank you for attending, and if you need to contact me, please reach out, and have a good day. Bye.